Okay, here we have motor control board for the pizza portals. The most common issue we get with these would be these parts right here. They are Omron transmissive photomicrosensors. These particular ones are the EESX 1041 models. That's basically a slotted optical switch or a photo interrupter. We see these go bad all the time when looking at the hardware diagnostic tool on the portal, and you'll see that a door position is not being read accurately. These parts are pretty cheap, usually $1, $1.50 a piece. They can be changed pretty quickly. If you have a board where the green LED is not as illuminated as it should be, or you see a bunch of question marks on the hardware diagnosis tool on the portal, this is not going to repair that. This is only for when you see that the position of the door is not being read accurately. And any other issues with these boards are repairable, but you do need to be able to diagnose what the issue is by checking resistances and values of the different parts on the board. Not nearly as easy as this. So we're going to go ahead and swap these parts out. And I'll give you an idea of how easy it is, how difficult you might consider it, and a little bit of best practices when soldering on something, especially something that tends to be as small as these. So most of the time, only one of these tends to be bad. I change both of them every time anyway. They go bad pretty often. Might as well do it while you're at it. On the opposite side of the board, you can see you got 4 pins for each of the photomicrosensors. This can be done without any specialized tools other than soldering station, and in this case I'm going to use a rework station. It does simplify it a little bit. Not entirely necessary, but the point of this is to show that you don't necessarily need to have a whole setup. As you can see here, I've got a cardboard box I'm using, a little bit of painter's tape to hold it down. I'll go ahead and add another strip right here just for additional stability. Just like that. Line it up. Now when I did this, my objective is to leave a gap behind it because I got to pull them out. I don't want the box to be in the way. I'm going to start by using a rework station. We're going to heat these pins until the sensor just falls right out. Alright. Got my rework station here. I'm just going to spread some heat. When working with a rework station, I don't like to focus in one spot for too long. You can warp the board. These particular boards don't have the biggest ground plane ever, but it does absorb heat relatively well, so sometimes it does take a little bit of patience. Just spread it over the area. My rework temperature, I typically keep it around 750 Fahrenheit. My airspeed on my particular unit is about 4.5. This does take a little bit of time, but it is one of the cleaner, easier ways to go about it. Now, while I'm heating it, now and then, I like to go up and grab the pin, just give it a little wiggle. None of them are moving yet, so we're going to just keep going. Checking every now and then to see if the pins have started getting loose enough to wiggle. There's no rush on this part. One thing to keep in mind, if you start pulling on the sensor prematurely or pulling too hard on the pins, you can rip the pads off the board. Makes a lot of extra work to repair them. Patience is key. Alright, I'll just gently grab the sensor, continue spreading the heat. I really don't want to be pulling on it. I want the weight of the sensor itself to do most of the work pulling these out. There we have the first one out. I can get the camera to focus. There we go. We're going to go ahead and get the second one. And because the ground plane on this is relatively warmed up from the first one, it should be a lot quicker to pull the second one out. Again, avoiding any prolonged period of time spent in the same spot. Reduce any warping that could possibly go on with the board. Alright, there's our second one. Obviously being careful since the board is nice and hot. But next we can take a look at it. As you can see, there's still a good amount of solder in between all of those holes. We're going to want to remove that. You could give it a shot with some solder wick, but I feel as though that tends to take a little bit more time and effort than I prefer. First thing I'm going to do is some 91% isopropyl alcohol. We're going to clean up the front of this. A couple sprays and a Q-tip. Back a little bit too. All right. So for those unfamiliar, this is a desoldering tool. Pretty simple. Push that in, click the button, causes suction on this end. So I'm going to get my soldering iron. Preset temp that I typically use on this is between 640 to 670 Fahrenheit. Of course, you can use whatever your preferred temperatures with both the air gun desoldering station or the rework station and the soldering iron. You do not want to be any hotter than necessary. You can warp the board, obviously, like mentioned before, but with the soldering iron, you can burn the board and have darkened spots or areas that just tend to be more damaged than others. So in this particular case, it's going to be kind of difficult to show as I go, but our goal here is to heat from one side at that hole, and then we're going to use the desoldering tool. We're going to line up with the hole that we're trying to desolder, put it right on there while we got the iron on the other end, press the button and let it suck it right out. I'll do my best to make that as visible as possible while doing the repair. So once your iron heats up, this is why we added the extra tape hook over here, so that we can have some extra weight on it. We're just going to go ahead and put the iron into that hole, line up this on the other side, press the button. Doing so, as you can see, has pulled the solder out of the hole. U6 letter C is now clear. We're going to do the same to the rest of them. They all cleared out pretty well. We will go ahead and, as you can see, they're all pretty clear now. We'll go ahead and pretend that U7 letter E here in this corner did not clear out well. So I'm going to go ahead and put that down. In this particular case, I would add a little bit of fresh solder to it. And that is about all it needs. A little bit of fresh solder, just a dab. As you can see, I filled the hole right over here. It flows through to the other side pretty well. Letter E is quite full. So we're going to go ahead and pull that out again. That fresh solder should mix with the older solder. Tends to make an easier time pulling it out. Do it a second time just to be sure. There we go. Now you can see everything's pretty clear. Clean my soldering tip a little bit. Now we're going to go ahead and install the new parts. So these are the replacement parts. One thing to keep in mind, if you look closely at these, you'll notice there are little bumps, little tabs sticking off. There's one right here, part way up. And there's one over here on the corner. Those have to be put in the right position. They correlate directly with these holes right here. Got 1 and 2 for that one, and 3 and 4. So each photo microsensor will need to be lined up the right way, or it won't sit flush and it won't work properly. This part's pretty straightforward. We're just going to line the little pins straight through the holes. They are a little bit flexible, so if they don't line up perfectly, you can just gently move them into place. Now that we got them nice and flush, each little tab is through its correct hole. I will pull off this piece of tape because we no longer need it supporting from that angle. In some instances, a lot of people doing soldering or during certain components, you can just bend the tabs. You bend them out, and it will hold it in place for initial soldering. I'm not a fan of doing that with these type of optical switches because we want the alignment to be absolutely perfect, and I like to make sure that when it's all said and done, the solder joint looks as close to manufacturer as possible. So as you can see, just put a piece of tape over them to hold them in place, verify they're still nice and flush. And now it's time to solder. First, we're going to get some flux paste. I prefer R08010. Has a good flow rate and obviously does a good job. First, we're going to put just a dab on each solder joint. Doesn't take much. But one thing to keep in mind is there's never such thing as too much. If you do put too much, it is perfectly fine. I'm going to try to elevate this a little bit, make it a little easier to see on camera. Hoping this angle makes it a little bit easier. So now this is just some basic soldering. It is relatively small, but should be relatively easy to do. If you don't have any previous experience soldering, just take your time. You don't need a lot of solder. You really only need enough to get it in, get the hole sealed. For those without much experience doing this, start by heating up the joint a little bit. Go ahead and touch your solder into place. I like to leave it there for a couple of seconds afterwards. Make sure it gets a good chance to flow. As you can see, it only takes a tiny bit. This joint right here, having a close look at it, may have been a cold joint. You can tell because it doesn't quite rise as much. Possibly this one too. So I always like to double check them. And I will just touch it up. It does not need any additional solder. Just gonna let it sit for a moment. Give that solder another chance to penetrate. Now we got all the joints soldered. We're gonna go ahead and take some flush cutters, trim off the excess material. As you can see, it's sitting flush. Everything's sitting where it's supposed to. Now we're going to get a little bit more isopropyl alcohol. And go ahead and clean it off. I like to use a toothbrush for it. It does make it simpler. The flux does not come off super easily, so the isopropyl alcohol tends to cut through it real well. In addition to that, of course, it dries without leaving any residues. Perfectly safe for electronics. Give it another shot. Joints are all cleared up. So check the other side. Sometimes the flux will run through a little bit or around the corner. Let's just give that a quick wipe. that's it. As I mentioned before, there are a lot of small resistors on this board. R76 here has had a tendency to be bad on a couple of boards that I've seen. I've also found somewhere R76 is broken off or partially snapped, likely from mounting or dismounting the board itself. Obviously these are much smaller and will be much more difficult to change, and that is assuming that you are able to diagnose the issue. Right here we have a replacement for R76, which is a 33 ohm resistor. To put it into perspective, it is a pretty small part and can be a bit of a challenge. That is one of those items that, if it is bad, it won't be obvious. You'll have question marks on the hardware manager or hardware diagnostics. But as far as door position sensors go, again, it's just a transmissive photo microsensor. It's EESX1041. The bottom numbers don't tend to mean anything. And it just happens to be manufacturer differences and dates. The top one is the particular part number for this slotted optical switch or photo interrupter, whatever you'd like to call it. If you have any questions regarding these, you can always reach out to me. If you have any troubles with them, I'd be happy to help in any way that I can. Unfortunately, doing any diagnostics on other components on these tends to require, at the very least, an oscilloscope, a proper resistive resonance multimeter, and a working knowledge of what these components are and what they should be doing with whatever voltage they are receiving. So it's not quite as easy to diagnose. So if you do have issues with other than the position sensors, then unfortunately this video is not for you. If you have any questions, feel free to reach out to me anytime. Thank you guys.